All right. So what were our rules? We had 5, right? The first one was corresponding angles. That's white, dummy. So we got corresponding angles. Postulate. What was that? You guys are just full of energy. So corresponding angles postulate, 2 lines that are parallel being cut by a transversal, right? Angles that are on the same side of the transversal and on the same part of their parallel line are what? And 2. What would we say about those 2 angles? They are congruent. So we'd say angle 1 is congruent to angle 2. So that was our first one. That was the corresponding angles postulate. And what does it mean for angles to be congruent? Equal. Our angles are equal. So if I had to put a number to it, if I said this, that's obviously, let's say 124, its corresponding angle would also have to be what? 124. Probably didn't do an effective enough job of that yesterday, so let's just go ahead and reiterate it before we get into math. Okay, what was our second rule? Let's go ahead and knock out both alternate rules here. Alternate exterior, we'll write that one first. Alternate exterior angles. And what did that tell us? So we got 2 parallel lines cut by a transversal. What was our rule there? Sorry. How are they related on the transversal? Opposite sides of the transversal, inside or outside our parallel lines? Outside. So angle 1 and angle 2. And then how would we say those angles are related? They're what? They're congruent. So angle 1 is congruent to angle 2. And what does it mean for angles to be congruent? Their angle measures are equal. So if this top guy here is 124, then our bottom one has to be 124. Yay! What was our other alternate theorem? What's that? Alternate interior angles. Absolutely. Alternate interior angles. So we have our 2 parallel lines cut by transversal. What was our rule? Excuse me, what was our rule? How are they related to the transversal? Okay, so but on the transversal, they're what? Opposite sides of the transversal, and then what about the parallel? Inside the parallel lines. You want to see something cool? What letter is formed with these 2? If I could draw one letter, what letter do you think it would make? A Z. So these guys always form a Z. I know I didn't show you all that yet. I was saving it. And how are these angles related? They are what? They're congruent. So we would say angle 1 is congruent to angle 2. And then what does it mean for angles to be congruent? What could I say about numbers? They are equal. So if that angle is 124, then this angle must be 124. All right, so y'all are waking it up. Y'all did learn a little something yesterday. Just had to get the brains functioning. All right, so we had one more C one. It was called consecutive interior, but what did I tell you you'd also see? Same side interior. What did y'all see more on the homework? Do you remember? Same side? I figured as much. Okay, so two parallel lines. Wop. Cut by transversal. Wop. So what's our rule? What's our rule for these? Well, how are they related to the transversal? Same side of our transversal, okay? And inside of our parallel line. So we've got 1, 2. How are these angles related? What's their relationship? They are supplementary. What's it mean to be supplementary? Yeah. So, man, y'all are waking up now to the big boss ladies out there. So the angle 1 plus the measure of angle 2 equals 180. So mathematically, what would that look like? Yeah. So angle 1, the measure of 1 plus the measure of 2 equals 180. This is our only supplementary rules. And let's talk about one more, because it showed up on my math lab, and it's a linear pair. You'll see linear pair. Actually, we'll talk about 2, because you're going to see them a lot. So we've got linear pair. That was one of them, right? Yeah. And then did this one show up? Vertical angles? Yes. That's my fault. It's a bad Mr. Coach. We lost the whole vocab day with this whole down losing a day a week. Okay, so if I drew a picture here, so a linear pair, got it, being cut by a transversal, and then vertical angles, it's just two straight lines cutting each other. All right. So let's think about if I just have a straight line, a length of straight line, what would its degree measure be? Do we know? What's the measure of a straight line? 0? Okay. So it can't be 0. It has to be something, but I like where your head's at. And so remember when we drew our XY? Yeah, so this was 0, then we went up to 90, then we got to 180. The measure of a straight line is 180. So if a line is cutting that, what is it going to do to these two angles? It's going to split them. And then what was that fun S word we just learned? Supplementary. So linear pairs are supplementary angles, which means their sum is 180. They will give you something. So this is just the definition, right? So I know the measure of 1, and I'm going to guess it's going to give us something when we start doing our algebra, plus the measure of 2 equals 180. So this is just our rule, but they're going to give you one or the other. They're not going to be like, here you go, guess. Because all we could then say, well, homework problem, all we know is that's 180. We don't know anything else. We can't assume anything else. That's going to be a fun day y'all won't like either. And then our last little rule that showed up yesterday is vertical angles. Do y'all remember what it said on the assignment? Vertical angles are what? Not necessarily. They can be anything. Okay, so they're directly opposite one another. So you guys see that X it kind of forms? This right here, like a little X. So across is our vertical angles. Vertical angles, guys, are always congruent. no matter what. This is a postulate. Vertical angles are always congruent. So we'd say angle 1 is congruent to angle 2. So those are some of the rules we're going to use today. Not too bad, right? There's only 4, 5, 6. All right, let's put it in action. So looking at number 1, it wants us to solve for x. So the first thing we need to do is identify the relationship they're showing us. What do we know about these two angles? They're what? They're on the same side of the transversal, inside the parallel lines, so we know what? Same side interior. Absolutely. And same side interior angles are supplementary. Same side interior angles are always supplementary. So if we go back to our rule for same side interior, we said the measure of 1 plus the measure of 2 equals 180. So that's our definition. How would I apply that to our problem? So it says equation. What equation would I draw using my two angles? Dude, you were on it. So you'd say 4x 6x equals what, Ethan? Well, what do we say about same side interior angles? They're what? They're supplementary. So the sum of those two angles has to equal 180. And now we just created a linear algebra problem. What's our goal in linear algebra problems? Solve for the x. How do we solve for the x? What's that? Yeah, we want to get that guy by himself, and eventually we've got to divide, right, Cole? So what would I do first? What would we do first? Do we have any like terms on the same side? So we're going to add together our like terms. Yeah, make a big old CLT sandwich. Combine our like terms. Now that we've combined like terms, what do we do next? Divide by 10. Absolutely. 180 divided by 10 gives me, we can just drop the zeros, right? Drop the zero, get with the zero, honey. Yes, queen. That's right. 18. So x equals 18. But it also wants to know the measurement of angle HFC and angle DBG. So what would I do to get those angle measures? Does that mean 4 and x are 18 degrees? That means x is 18. So what do I need to do to find the measure of the angle? I need to substitute 18 in for the x. So I'm going to substitute 18 in. And you guys are going to figure out in a couple of days why I'm being so specific with the words I'm using. Proofs. 4 times 18? Or 36 times 2? Close. Further away. 72. Now, without even substituting x, what do we know that bottom angle needs to be? whatever this angle is, that plus 72's got to be 180. So we're going to guess 180 minus 72 is 108. So let's see what happens when we substitute 18 for x. 6 times 18. Somebody calculate me. You guys have calculators. You weirdos. Well, you might want to charge it. This is definitely a calculator unit. It's 108. You did. It has to work or I did something wrong. So it's kind of nice that there's like a little built-in check system. If when I multiply 6 times 18 and I don't get 108, I done jack something up, Chuck. Not too bad, right? Algebra and math?
Is it that same rule for every single one?
Nope. Remember, we had 6 different ones with 6. They're either congruent or they're supplementary. There's no extra. So they're either equal or they add up to 180.
Oh.
What's that? All right, Cole says these ones are equal. Is he right? So we've got, oh, Peter, you need a highlighter, dummy. It looks kind of whack, yo. So what do we got? Opposite sides of the transversal outside of my parallel lines, we've got alternate exterior angles. Alternate exterior angles are congruent or supplementary? They are. So if we go back to our rule, alternate exterior angles are congruent. We said 1 is congruent to 2, right? That's the definition. So when I look at my problem, how would I draw out my equation? If angle 1 is congruent to angle 2, and technically this would be angle 1, angle 2, 6x equals 3x plus 72. My man. Not too bad, right? So now we've got our equation. What do we do with our equation?
Wait, so when you're writing the equation, is it always going to be like the same for whether it's congruent or supplementary?
Yes.
So it's always just going to be using the numbers?
You're either using the congruent or you're using supplementary. And we're only going to do 2 angles at a time. Yep. We're not going to get too crazy and go with a bunch of different. So we're solving a linear equation. What's our goal in a linear equation? Get the x by itself. So I've got x's on different sides of the equal sign. So we probably need to put them on the same side, right? So who would I move? I'm going to move the 3x. And since the 3x is positive, how do I get it to move? You subtract it. And what I do to one side, got to do to the other. It's going to cancel that one out for me. It's a big old fat marker. So 6x minus 3x is 3x equals 72. Is the x by himself yet? Nope, he's got that 3 hanging on. It's being multiplied together, so I'm going to divide. So x is 24. I'm not quite finished yet. What would I do next? I need to substitute, aka plug it in. We're going to substitute x into our angles. So ABC, the middle number tells you what vertex you're using, or the middle letter. So we're substituting 24. So 3 times 24? 72. And 72 plus 72 is 144. All right, without doing any math, we must get what from angle GFE? We probably need to end up with the same one, GFH, sorry. So let's go ahead and substitute it and check ourselves. 6 times 24. Plug it into the El Calculadora, beep, bop, boop. What do we get? 144. Excellent. Any questions before we keep moving forward? No? All right, let's do one more. Which one y'all want to do? 4? 4's probably a good one. Or 3. I guess they're the same, aren't they? 4 is a decimal? Yeah, we're still just multiplying by a decimal. It's okay. All right. Let's look at 4 because 4 has a decimal. And it's freaking us out. Do we have a relationship between our two given angles? Would they be supplementary? Why? Why aren't they congruent? Okay, they're on different sides of the transversal. Are both of them inside? Nope. Are both of them outside? Nope. So that won't work. We could use vertical angles if we want. Or do we know a relationship between, give me a different color, dang it, 3, 5, and F? Is there a relationship there we can use to our advantage to help us solve for X? Same side of the transversal, and they're both on top. What do we call that? We call that corresponding. So they're corresponding angles, right? What do we know about corresponding angles? They're what? Corresponding angles are congruent. So what could I do with 3.5x? Since Gabby doesn't like decimals. What can I do with it? If I know 3.5x and f are congruent, how can I manipulate this problem to help me solve it? What's that? I'm going to substitute that. I'm going to take 3.5x, and I'm just going to plug her in down under. And now this is going to be 3.5x. Now we did this rule. I just showed it to you. We're on the same line cut by a transversal. What do we call it? No, it's one of the new ones I just said. It's either linear pair or vertical. Linear pair, how do I know? It's on a line, and there's two of them. What's wrong? Oh, you're good? Okay. So it's a linear pair. And in our linear pair, is that a congruent relationship? or a supplementary relationship? It is supplementary. Which means what? Their sum equals 180. So how would I write that as an equation? 3.5x plus 4x equals 180. So at the start of this problem, we did not have a direct relationship between our Euler angles. But using our rules, we were able to manipulate our figure to get us into a situation where we could solve for it. Now that I've got it down there, what am I going to do? Yeah, we're going to solve it. So we got 3.5x plus 4x equals 180. Right? What's the ultimate goal in solving linear equations? Isolate our variable. What do I need to do first? Combine like terms, make ourselves a CLT sandwich. 3.5 plus 4. 7.5 equals 180. Is my x by itself yet? Nope. What do I need to do? Divide by 7.5. Somebody calculate us, please. 180 divided by 7.5. 24? Crazy. So we got 24. Don't put a degree mark there, dummy. Okay. Let's plug 24 back into the x's. So if we want 4x, let's go there first. What would, so 4 times 24 gives me 96. And then 3.5 times 24. It's going to be a little different. But it's okay. What do we got? 84. And what rule did we use to help manipulate it first, the corresponding angles, to get to our linear pair? 84 plus 96, do they equal 180? Absolutely. All right, your homework is this right here. I am going to leave this little rules piece up on the board, and you guys can start after your homework. It ain't due till Monday at 3 p.m. No, it's on my math lab. Da, 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 da.